morning children. Now we are going to see the chemical kinetics last part. Till now we have discussed about rate, order, molecularity, half-life period, collision theory, Arrhenius theory. Okay, all those just we have learned about the rate. Okay, all those things are explaining only about the rate. Now the last part of this lesson, what are the factors can affect the rate of the reaction. Rate means what? Speed. Overall can affect the speed of the reaction. Now the factors affecting the reaction rate are nature and state of the reactant, concentration of the reactant, surface area of the reactant, temperature of the reaction, presence of catalyst. Okay, these are the factors can affect the rate of the reaction. Okay, the first one, nature of the reactant. Some reaction will take place normal room temperature. Some reaction we have to heat, then only the reaction will take place. Just for example, the redox reaction between KMnO4 and FeSO4, ferrous sulfate. Okay, in 12th standard we are going to do this one as a practical. Between this reaction, the reaction will take place immediately. Normal room temperature is enough. Directly we can add KMnO4 and FeSO4. We will get that pink color. But the same for oxalic acid. Same redox reaction between KMnO4 and oxalic acid. At normal room temperature, the reaction does not take place. We have to heat this oxalic acid first up to 60 degrees Celsius. Then only we have to treat with KMnO4. Finally, we will get the end point, that is pink color we will get. Okay. So, same type of reagents all are in liquid state only. Even though we have to heat for oxalic acid, it requires some amount of temperature. But for ferrous sulfate, no need. Okay. So, like that, based on the reactant nature, the rate of the reaction will increase or decrease. Okay. So, nature can affect the rate of the reaction. The next one is state of the reactant. What are the physical states of matter? Solid, liquid, gas. Okay. Easily you can say among these three states, which will undergo reaction fast? Good. Really gaseous state. Okay. So if the reactants are in gaseous state, the reaction will be very fast. Then liquid, then solid. Okay. So just for example, let me show one reaction here. Now this is lead nitrate and potassium iodide. Okay, now I am going to take this lead nitrate and potassium iodide in the solid form. Lead nitrate and potassium iodide. Okay, now I am going to mix this both in solid form. See, I have mixed. The color is changing to yellow color. But it is taking time. Can you see the yellow color here? See here, it is changing into yellow color, but it is taking time. Okay, now the same reaction I am going to do with liquid state. Okay, now this is lead nitrate, potassium iodide, both are in liquid state now. Just let me add this. See, suddenly the yellow color is coming. Okay, now among these two, which reaction is fast here? Whether in solid state reaction or in liquid state reaction? Liquid state. Okay, so when the reactants are in liquid state, the reaction will be faster than the solid state. Okay, so the state of the reactant also can affect the speed of the reaction, rate of the reaction. The next one, concentration of the reactant. Here in collision theory we have discussed, according to the collision theory, the molecules will come and collide with each other, then only the new bond will form between them. Okay, so here the concentration is more number of collision will take place, so we will get more number of product. Okay, so when the concentration is more, the speed of the reaction also will be more. Okay, if the concentration is less, then the speed also will be reduced because less number of ions or atoms or ions are present. then the reaction also will be slow. More number of constant which we need is present means the collision also will be maximum, then the product also will be maximum. So concentration can affect the speed of the reaction. Then the third point here, surface area of the reactant. Okay, surface area. If we take the same mass of a particular compound in solid form as well as in powder form. Just for example, limestone, we can take calcium carbonate. Okay, calcium carbonate. When you treat calcium carbonate with hydrochloric acid, you know what is the product? We have done this one in 11th standard public practical. Calcium carbonate plus hydrochloric acid, which will come out? Good. Carbon dioxide. Carbon dioxide gas will come out. The brisk effervescence we will get. Okay. Suppose I am taking this calcium carbonate in marble form, in stone form I am taking, and then I am adding hydrochloric acid. Okay. I will get carbon dioxide, but I will get slowly. Okay, because it is a marble. Okay, it is in stone. It is in the form of solid. Okay, so it takes more time to react the hydrochloric acid. But in the form of powder, easily it will react. Suddenly, if you add hydrochloric acid, you will get brisk effervescence. Okay, so surface area of the reactant can affect the rate of the reaction. Then temperature of the reaction. Okay, before itself I said some reaction requires temperature rise. Okay, same way here, the same reaction when you are doing in the normal room temperature, the reaction will be slow. It will take 4 minutes, 5 minutes, okay, even 10 minutes. Suppose if you heat that solution and if you do that work, the reaction will be very fast. Okay, why? What is the reason? Because when we are heating that reactant, the collision will be increased. The molecules will collide with each other in more number. Okay, so the product will get in more way. Then, so that the speed of the reaction also will be increased. Okay, when temperature increase, the speed of the reaction also increase. Here, one exceptions are there. We know in 10th standard we have learned endothermic reaction, exothermic reaction. Okay, so for exothermic reaction, okay, when the temperature, based on the temperature in endothermic reaction, when temperature increases, the speed of the reaction also will increase. For exothermic reaction, we have to reduce the temperature. Like that and we have learned. Okay, so not for all reaction, for some reaction, when we are increasing the temperature, the speed of the reaction also will increase. Okay, finally, presence of a catalyst. Here, presence of a catalyst. This catalyst, just you must know what is this catalyst first of all. Okay, this is a chemical compound which involves in a reaction, but at the end of the reaction it will come as it is without any physical or chemical change in it. Okay, how we have introduced in the beginning, in the same way it will come at the end. Then what is the purpose of adding this catalyst means? Here it will alter the speed of the reaction. Okay, in the 1 mark also they will ask. It will reduce the speed of the reaction or increase the speed of the reaction, like that they will give. Okay, you have to choose the option. It will alter the speed of the reaction. That means we are using the catalyst to reduce as well as to increase the speed of the reaction. We can enhance the rate or we can reduce the rate using the catalyst. Okay, in the 12th standard we are going to learn types of catalyst also. Okay, positive catalyst, negative catalyst. That means which we are using to increase the speed. That is positive catalyst. The catalyst is used to reduce the speed are called negative catalyst. Okay, so here presence of catalyst can increase or decrease the speed of the reaction. Okay, so at the end of the reaction it will come as it is without any change. Okay, it will involve in the reaction. Here in collision theory we have learned the reactant must possess some amount of minimum energy. Okay, which is required to collide with each other. That energy is nothing but activation energy. Okay, so it must possess that activation energy. Okay, then it will attain the intermediate state. After attaining the intermediate state, it will be converted into product. Like that we have learned in collision theory. Okay, this energy is called as activation energy. Okay, this activation energy when we are adding the catalyst, it will be reduced. Okay, when the activation energy is reduced, that means the minimum energy which is required for a collision is reduced. That means more number of reactants can involve in the collision. Okay, only few molecules are involving in collision. Other molecules are not involving because they are having less energy than the activation energy. Like that we have learned in collision theory. Okay, when we are reducing the activation energy, the activation energy itself we are reducing. That means more number of reactants can involve in the collision now. Okay, so we will get more product. The rate of the reaction also will be more. Okay, so you must remember the catalyst will alter the speed of the reaction. When we are adding the catalyst, the activation energy will be reduced so that more number of reactant can participate in the collision, which leads to the formation of product. Okay, so that's all, children. Just go through what are the factors can affect the rate of the reaction. Okay, we can expect this one and one 5-mark question. You have to explain all the 5 points. Okay, just go through in your book, and if you have any doubt, you can ask.
Today is factors affecting rate of reaction. Wait, what is rate of reaction? Rate of reaction is the rate at which chemical reaction proceeds. In simpler terms, the rate of reaction is how fast or how slow a chemical reaction occurs. But how does a chemical reaction occur? Reactions occur when two or more molecules collide with each other and must possess enough activation energy, which is the minimum amount of energy needed to start a reaction. Chemical reactions in general proceeds at different rates. The difference in rates of reaction is caused by several factors such as concentration of reactant, temperature, particle size, and presence of catalyst. Let's start with concentration. If the concentration of a dissolved reactant is increased, the reactant particles become more crowded. Therefore, there is a greater chance of the particles colliding. Thus, the rate of reaction increases. We can now conclude that the relationship between concentration of reactant and rate of reaction is directly proportional, since the higher the concentration, the faster the rate of reaction, and the lower the concentration, the slower the rate of reaction. Next is temperature. Once a substance is heated, the particles move more quickly and they have more kinetic energy. The particles collide more often and more of the collisions are successful. The rate of reaction, therefore, increases. Same with concentration, temperature is also directly proportional to the rate of reaction. As temperature increases, the rate of reaction also increases and vice versa. Particle size. Smaller reactant particles provide a greater surface area, which increases the chance for particle collisions, so the reaction rates increases. Therefore, larger particles have small surface area, while small particles have greater surface area. If the surface area of a reactant is increased by cutting the substance into small pieces by grinding it into a powder, more particles are exposed to the other reactant, increasing the rate of reaction. Presence of catalyst. Catalysts, for example, enzymes, lower the activation energy of a chemical reaction and increases the rate of reaction without being consumed in the process. Catalyst works by increasing the frequency of collisions between reactants, altering the orientation of reactants so that more collisions are effective, reducing intermolecular bonding within reactant molecules, or donating electron density to the reactants. Therefore, we can say that the lower the activation energy, the faster the rate of reaction, and the higher the activation energy, the slower the rate of reaction. That's all for now, and I hope you have learned something. Thank you and goodbye.